doing some business calculus. She had a 20 or something on the first test. And the first test is a predictor of how well they're going to do in the final test. Just like in bio class, when you have two things that are correlated to each other, you see the regression line through it in Excel. So if I take first exam grades in any class I have and look at the final grade, I can get those graphs and a significant correlation between them. So I mean, I told the same thing to the class that I just told you now. Try this idea of making up tests. Her next test grade was a 96. And I looked at her and I said, how did you get this? She goes, I just did what you said. I made up sample tests for myself. So it works. All right. Again, I'm writing things that I probably shouldn't have written, but these are hard because you can transform the left side in so many different directions. How do you know that you're going to hit on the exact expression that they want you to hit on? So I'm not going to ask you the question like this. I'm going to give you the top and give you this and ask you to reach the bottom from the top. Or you could get the answer and then show they're equal. Same old, transform everything to sines and cosines. I don't know why that went sin x. Oh, it's sin x times x. Okay, so it's like same old stuff, right? You get a common denominator, combine the fractions. So I'm doing the same thing. So sine times sine gave me the sine squared over cosine squared. I've got a fraction over another fraction. I get a common denominator. I'm getting sleepy just talking about it. It's the same thing. Multiply top and bottom by cosine and get a common denominator. I can't do that other trick where I just did cosine over cosine because there's no 1. So I have to take this sin x and multiply top and bottom by sin x. And then I get fraction over a fraction. And what do you do now? Invert the denominator, multiply. I'm going to keep making you say it until you just invert the denominator, multiply. I taught at West Point for a couple of years. That was a great job because I made them memorize it one by one. They had to stand up. Man. They rattle off all their laws and rules. So they had them down, and I can make them do it. It was a dream. So invert the denominator and multiply. Cosine slash out. I'm left with sine squared over sine minus sine cosine, but I can factor out the sine. Can you go like this? Can you cancel like this? No. But you used to maybe when you're small, but you don't do that anymore. Now you factor out, and then you slash. And then leave it. Sometimes students want to keep working on it. It's done. It can't be put down anymore. So what I'll do is I'll ask you for this to be the end rather than those crazy forms that they gave you in WebAssign. And it might just be an artifact of automatically making those. You can imagine you're in IT. How would you program that? So that it's a different problem for every person and it's something that they have to reach to. You probably can't come up with one thing that is. That's what I think is probably going on. So what I'll ask you is instead to change that tan to sines and cosines and reduce as much as you possibly can. So it's much more straightforward. What do you think? Good? Thumbs up? Thumbs down? We'll see after we look at the videos. Okay, this one, they want you to change this to sines and x and cosine x, so no pi over 2 in there either. Secant of a mess is always 1 over cosine of that mess. So it doesn't matter that it's not an x in there. Whatever is in there, it's 1 over cosine of that. And I'm here at the unit circle, which is correctly written down. What I notice here is there's some patterns. Cosine is always the x coordinate. If you look at the progression of cosines, 1, square root of 3 pi over 2, square root of 2 over 2, and 1 over 2. Check this out. Those numbers on the y's are exactly in order that I've done in green, are exactly the x values that I got from there. You see that? The 1 I got here is the same y value I got there. The square root of 3 over 2 I got here is the same y value up there. It's like all the x values turned into y values as I went around the other side. What are the y values on the unit circle? The sines. And what are the x values on the unit circle? Cosine. So that's the relationship between cosine and sine. It means that cosine at t is equal to sine t plus pi over 2. It's pi over 2 off. The y values start kind of at pi over 2, right? So just to check that I got this right, I just stuck in t equals 0 to make sure that I got it right. Cosine at 0 is 1, and if I plug in t equals 0 into the sine part, I get sine pi over 2, which is 1. I believe it. I only need one example. I believe it. Believe it? Likewise, what if I went down this side and looked at all the x values for cosine? The x values here are all negative. The y values here are all positive. But the x values, if I go counterclockwise, are 0, negative 1/2, negative square root of 2 over 2. They're exactly the same as the y values here. See that? Except they're off by a negative. You agree? Do you agree? Do you agree that the yellows are exactly the same thing as the greens, except off by a negative? You see it? You see it? I'm going to wake you guys up. You're sleeping with your eyes open. How come when I teach my own kids, they don't shut up? I'm trying to teach them something, they want to talk while I'm teaching them, and you guys are like... So we get minus sine pi. I just checked one. Does this work? Yeah, it works. They match. So I just plugged in one value of t to make sure I'm right. And the reason I do that is I'm actually pretty sloppy, so I'll end up making a mistake when I run too fast. Okay, so I wrote my relationship down. 1 over cosine is the x values turned out to be the negative y values, so I just replaced it. And look at that. It was one of the answers. Unit circle is pretty cool. It just tells you everything you need to know. Brother, there's another one. Rewrite the given expression in terms of sine x and cosine x. This idea of getting used to these problems is really huge because they're the kind of things where you sit in calculus or calc A and you say, you know, you do that on the board and then everybody goes, why'd you do that? Like, who did you have for pre-calc? That's where you should learn this. That's the kind of thing. Like, you have to get used to it. You can't just do one problem. Remember, S-O-N-G. If you can't remember and they say, who'd you have for pre-calc? Song. I'll have them come down one day. We'll tell them, I'm blaming you for anything that goes wrong in here. Tangent x minus pi. Well, let's transform it to sine and cosine. That's sine x of minus pi, cosine x minus pi. Well, I'm just going to check this. What does that equal? Just like with the pi over 2 thing, I just went back and checked. Subtracting pi, what does that do? I took sines are the y values. I just took a random y value, and I shifted over by negative pi. Negative pi goes clockwise. What happened to that y value? Is negative. So it looks like when I shift by pi, I got a negative value. What if I take cosine x minus pi and do the same thing? Well, look at that. They're off by negatives too. So I get the relationship. So cosine x minus pi is negative cosine pi. Drop it in, and I get sine over cosine, which is really tangent. But they just wanted me to stop there. Good so far?